See, you can see that you have a graph here. You have a graph here. The graph suggests that you can see in this, the graph suggests that potential energy as a function of something was given to you. Right. Just erasing all this. Now you can notice that, see, when potential energy as a function of x is given, which means any force involved will be correct, conservative force. Now, one more important point is it possesses 1 joule of kinetic energy at x is equal to 1 meter. Fine. Notice that at x, this is x is equal to 1. X is equal to 1, you can see it has 3 joules of potential energy. So therefore, the total energy is kinetic energy plus potential energy. 1 plus 3, which is equal to 4 joules. So it should not have any total energy more than 4 joules. Now you see this, the total energy here should not cross this line. This is 4.0. Correspondingly, this is 6.0. Now, after this, we have nothing to do. You won't even cross that. The moment you reach x is equal to 6, kinetic energy is equal to 0. You won't cross that point. Why? Total energy is 4 joules. At x is equal to 0, kinetic energy is 0, potential energy is 4 joules. So therefore, where will it reverse its direction of motion? At x is equal to 6 meters. How do you know that it reverses direction? My point is very clear. My point is very clear. Sound record. My point is very clear. Why should it return set? Why should it return set x is equal to 6? It can stop also. Stable equilibrium, how do you know? No. No. Remember, the graph says f is equal to du minus du by dx. Slope is positive, so force is negative. Means at this point, at x is equal to 6, this is x is equal to 0. This is x is equal to 6. Yet x is equal to 6, it experiences a force towards the origin. So it will enter. The K is 0, it will stay there. No, it won't stay. Because there you have positive potential energy. Don't say stable. You say that it is not an equilibrium. All equilibrium based models will come under next week. Right. Any doubt in this question? May I proceed further? Right. I'll go through this question now. Ball of mass M is suspended from the ceiling with the help of an elastic cord. You can see that this is an elastic cord, not spring, cord. Right. An additional downward force applied on the block. Again, read this point very carefully. If increased gradually, slowly, and always it is in equilibrium, to a value F naught, the cord will break. So the maximum tension that the cord will break is what? Weight of the ball plus your force. That is the maximum tension that the cord can bear. Understood? This is the first point. What should be the minimum constant force that will break the cord? Now you see here, normally the spring is relaxed. Boys, normally this is the relaxed length of the spring or cord, no issues. Now you suspended the weight. As a result, there will be some elongation. You know that. We learned that in laws of motion, which clearly implies that how much is the elongation? Mg is some kx1. So therefore, x1 is mg by k. This is the stage. Now, before you start the problem, this is the situation. Here now you applied some force gradually. You dragged, and you reach this point where the cord breaks, snaps. For this purpose, additional elongation is x2. Additional elongation is x2. Our total is x1 plus x2, out of which this kx2 is due to f0. Now, if you have any doubt, you will face the doubt at this point. You please try to follow, and you can question me if required. అందులో ఏమైనా డౌట్ ఉందా? F0 అంటే నేను ఇంట్రడ్యూస్ చేసింది మీకు ఓకేనా అంటే if your cord is extended till x2, already by default it has an extension of x1. If the further elongation is x2, then what will happen is it will snaps. That tension this cord cannot bear. Now what is going to happen? Now what happened is, now you started applying some constant force and you are drawing from here to here, whatever it is. Work done by my force, work done by gravity is change in elastic potential energy of the spring according to law of conservation of energy. This is as per law of conservation of energy. And you set a minimum constant force. So force into displacement. If the force is constant, force into displacement. Fx2 plus mgx2 is half k x1 plus x2 whole square, total elongation square, minus already in this state there is some elongation, x1. F plus mgx2 is, after solving you will get 2x1 x2 plus x2 square. So what I have done is, here x2 is common, here also x2 is common. So finally what I have is F plus mg is equal to kx1 plus k by 2 x2. Bhaiya, mg or kx1 is the same. Cancel. So F is k by 2 x2. But I know kx2. Where do I know kx2? Here I know kx2. And that is nothing but f0 by 2. Please go through this question. If you have any doubt, please ask me now. If you have any doubt at any level, please ask me right now. Remember, do these questions come? Okay, my answer is different. If you don't have these questions, don't you learn this? Remember, these questions will allow you to think in a different way, different frame according to me. That is the reason why sincerely I have solved all these questions to maintain time. So I have targeted some 10, 12 questions. Let me see. My average strike rate during this time is maximum 4 to 5 questions. Right. Yeah. This is one question which is an easy question. But see, there are 5 lines in that. Study the each line carefully. A raindrop of mass m at a height h starts from rest and initially accelerates under gravity. Due to viscous drag of air, its motion is resisted and finally acquires a constant terminal velocity. This is a fact, actually. Right. And hits the ground. Neglect the buoyancy. Denote acceleration due to gravity by G and assume no wind. Magnitude of average viscous force on the raindrop during the entire downward trip is. See what is happening here. Here, this is the drop. This drop initially experience a weight force that drives it downwards with a velocity v. There is another force called viscous drag, which is exactly opposite to the velocity. So the moment it keeps moving down, gradually acceleration decreases. At some point, when acceleration becomes zero, velocity becomes a terminal velocity. इसका मतलब है कि it means thereafter there is no increase in speed. The same speed it will strike the ground. Otherwise, if there is no atmosphere and there is no viscous drag, a raindrop that starts from a height of a minimum of 3 or 4 kilometers will strike you with a speed greater than the speed of a bullet. No mankind will survive with that footing. Yes or no? So therefore, thanks to atmosphere. Atmosphere helps in two things actually. The tiny droplets, actually that such a droplet will not form as per surface tension. Because such a small drops, the pressure inside the excess pressure, it is called in surface tension, you will learn. In such a small drop, pressure is so high that such a drop won't form. But how small drops are forming? In atmosphere, there is a dust particle. During the process of condensation, on the dust particle, condensation takes place. So that dust particle will help in the formation of the drop. And that drop is falling now. Gradually, around the surrounding air will exert a viscous drag upwards, and somewhere, some point, you will see terminal velocity. Or you tell me whatever it is, only two works are happening. Work done by viscous force and work done by gravitational force. These are the only two forces I know, which is equal to change in K. Right. You said it has fallen through a height h. And you are asking average force. So what is the work done by viscous force? Actually, if you ask me, honestly speaking, I should write this as dy. But since you are asking about the viscous force, I can write this as h. I can write it like that. I think you got my point. So therefore, minus F average H plus, of course, Mass of the drop remains the same. mgh is equal to half mvt square. So what do you want? F average. F average is mgh minus half mvt square divided by h, which is nothing but m times g minus vt square by 2h. Right. Do you have any doubts in this, boys and girls? Are we clear? May I proceed further? Okay, you're not smiling here. Teaching good now. Mid fine. Good. Looking good. Yeah, seriousness. Right. Yeah. This is one of my favorite questions. One of my favorite questions. The theory question, basically. Two identical ropes, you can see A and B. You can see the ropes clearly. भैया rope ऐसा के ऐसे जा रहा है ऐसा के. That is how the ropes are. You have a tube, you can see that here. Pass through almost massless, inertialess means massless. Metallic rubber structure C, you can see there, as shown in the figure. The structure is made by welding two identical bent tubes. There is no friction between the ropes and the tubes initially, Initially, the structure is held at rest. Just ऐसा hold करके just released. Then what happens? Obviously, the tube will keep moving down. The tube will keep moving down. Now see, I am just drawing the free body diagram of half of the left, the left half of the tube. Did you see the tube? System. Right. Okay, fine. Now my second question. Second question is, did you see the rope in this? Previously red color highlighted was a tube. Now the blue color highlighter was the rope. The problem is the rope massive or massless? If it is massless, I have nothing to do in this question. I'll simply say nothing happens. Rope is massive. That's the problem. इससे क्या होता है कि ना, actually you said that the YouTube will have some acceleration A. Now I am in the reference frame. This is me. I am in the reference frame attached to the YouTube. You not YouTube. This I don't know what you call this tube. Otherwise, bent tube. So in my frame, the rope will have an upward acceleration as well as the rope will have a leftward acceleration. Now why? Upward acceleration, you are convinced because you are in a frame which moves down with A. So you expect any massive particle will have an acceleration A up. That you agreed, right? Next, how do you know that the rope will have a leftward acceleration? Superman. That's why I like you people. You should think in that way. See, when the tube have gone down by some x distance, the same amount of rope is going up in the reference frame attached to this. So when this end is having a acceleration up, this end should have a acceleration leftwards to conserve the length of the tube, to conserve the length of the rope. How many are convinced in my explanation of this free body diagram? Right, most of you. Can I take sigma y on tube? Take the tube only. Now you have one tension T1 up and one tension T2 down, weight acting down, and all this results A acceleration upwards. So therefore, I have written T1 plus MA is equal to mg plus T. Got the point? This is for the tube I am writing. Right. Next. Now, you take for the rope. You take for the rope. Only for this part of the rope. You take for the rope. You take for this part of the rope only. Rope only. This part of the rope. If you take this part of the rope alone, so what is happening here? In this part of the rope, you have tension T1 here, tension T2 here, and you committed me right now this entire part whose mass is considered to be M. Remember what is M? Don't get confused here. M refers to mass of rope enclosed in tube, left tube, for clarity. Now in this case, the entire portion is of mass M, who is having A acceleration leftwards. So T1 minus T2 is equal to MA. Now what I am going to do is, I am going to use both these equations. By using both these equations, what I will get is, by using these two equations, I will get 2MA is mg. So A is G by 2. I am repeatedly telling you this is applied for tube. And this is applied for only rope X direction. Till this point, any doubt? So what did I prove? What will happen? It will move down. What will happen? There is no frictional force between the ropes, and initially the structure is held at rest and then released. For the structure, the acceleration is 0.5 g. That's what I have. Next, the rope will heat up. How do I know the rope will heat up? Don't say there is friction and all that. There is nowhere it is mentioned friction. No, we know, no, sir. There will be grip, and as it goes up, because of the friction, heat will evolve. No, no, nothing like that. For this purpose, you need to convince this diagram. In this diagram, if you notice, the moment when I observed, the tube is here. When you see that, the tube is here. Now try to please understand. Say, for example, this part is of length L. See the center of this. The moment when it reaches this point, the center which was earlier here is now here. Maybe this portion at that instant may have some velocity v. That instant, this one is having some velocity v. The entire portion of the rope will have some velocity v leftwards to conserve the length of the rope. Now what is happening? Entire thing is at rest. Two things you need to observe. See, these two comparisons, nothing changed. Previously rest, now also rest. Any change you observe is for this length of the rope. This length of the rope at a given instant, when the tube is at that location, it has some velocity and it is at some height. Now what is happening? Now it is aligning some position like this. This center, which was supposed to here, is now here. So this element lost potential energy. This element lost kinetic energy. Where do you account all these things? You are not accounting that. You are not accounting that. So all that last part is what we will call as conversion to heat. Excellent question. Now see, is my any mathematics part becomes the criteria for solving this question? Very simple question actually. You can see a frictionless rod AB and a point P of mass M. You can see that here. Point P of mass M are lying on a frictionless horizontal floor as shown. You are seeing actually the top point of all that is on the floor and you are seeing on over the floor. Your eyes are above the floor, right? The portion AB of the rod is bent to form a quarter of a circle. The rod is suddenly made to move with a constant velocity V towards the right along BC, which means you are taking this portion in this direction. Right. What is the work done by the rod on the particle till it leaves the rod? For this purpose, to analyze, let me be a person attached to the frame of this rod. For me, in fact, rod is not going. For me, what is going? It is the particle that goes. It goes, yes, sir. Means with respect to me, by the time it reaches, it will have a velocity v like this. It will have a velocity v like this. Right. Remember, you are having a velocity v like this with respect to him. But with respect to ground, you have two components. One, okay, this is the one. Two, the velocity of this bar also. Together, you have two components, V and V. So totally, what is kinetic energy? Half m v square plus v square. Vx square plus v by square. V square plus v square. Half m, in fact, what is this going to be? Total kinetic energy is half m v square plus v square, which is nothing but mv square. Any doubts? Next question. Read the question very carefully. One end of an elastic cord is attached to a block of mass m, and the other end is held, keeping the cord relaxed. Just holding it like this. You may question me, sir, you are cheating us. Springs comes under next week, springs come under next week. But who knows? Cord comes under this week. Then why should we miss the opportunity? Right. If the upper end is slowly raised, the block leaves the ground at some point. Remember a point here. There is a mark P, which you can see it on the diagram. And its height is at 0.8 L. If the upper end is slowly raised, you are raising it slowly, because of which it will stretch gradually, stretch gradually, stretch gradually. So how much it will stretch? It will stretch in such a way that this point P will reach this level when at the same instant the block loses the contact with the ground, which means the tension in the cord at that moment is mg. This is the first point to note. The second point, initially this length is point L, that length is point 2L. Finally, this entire length is 0.8 L final. And that is 0.2 L final. Okay, that is the chodo. 0.8 L final is nothing but 0.8 L final is nothing but the initial length L of the string. So L final is 5 by 4L. What is L initial? That I know. The total final length of the chord is 5 by 4L. So the elongation is 1 by 4L. Next, at this stage, you are exerting some force F, which is equal to this force F is equal to elongation K delta L. But K delta L is nothing but mg. Keep this in your point. So I have studied 2 points in this question. Okay, I have understood 2 different points in this question. Now I am stepping into the last point. What do you want finally? Work done by the force applied by the hand. Whatever the work you have done, it is stored in the form of the elastic potential energy of the string. So half K E square. I told you if it is a spring, half K E square. Half K delta L square. This I can write it as K delta L by 2 into delta L. K delta L already you committed that is mg. mg by 2 into elongation already you know which is L by 4. So totally mgl by 8. Any doubt? Pakka? Right. See, right. Next question. Everyone try to please read the question carefully. Everyone try to read the question carefully. A small block starts sliding down from point A on a slide of an irregular shape as shown in the figure. Here X and Y axis represent the horizontal and vertical directions respectively. The coefficient of friction you have given 0.6 which is nothing but 3 by 5. Area radius of curvature fine is large enough and the speed of the block is very, very small. You know, I have taught you some theory earlier. What was that theory? I'll just show you. I don't know whether you observed this or not. This is the theory. I don't know whether you observed it or not. If it is it's an inclined plane, fixed inclined plane. You are slowly, okay, hauling it up onto the top of the inclined plane. The work done by the friction is mu mg cos theta into L. L slanting length of the inclined plane, but L cos theta is x. This is the fundamental observation. So work done is minus mu mgx. Sir, I have an irregular shaped inclined plane, blah, 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 likewise. Then, even in this case also, you do small, slowly you are howling. So, mu mg cos theta d L, you will write. Cos theta dl term is always dx. So, again, integral dx is the total base length x. So finally, the work done by friction in this case is minus mu mgx. You are not allowed to use this formula under one condition. What is that? If you are not moving slowly up, you are not allowed. Because if you are moving slowly only, normal reaction is mg cos theta. If you are moving a bit faster, like for example, you have a curvature like this, and the object is say moving with some velocity v like this. In this case, maybe this is one component mg cos theta. You know, this is normal reaction, and by the way, this will have a pseudo force mv square by r. Now tell me, in this case, normal reaction is more than mg cos theta. Suppose if the portion is like this, then what happens? This is how your normal reaction is. This is how your mg cos theta is. And this is how your mv square by r pseudo force is. In this case or in this case, normal reaction is not equal to mg cos theta. In that case, you cannot have this relation. But if you are slowly moving, normal reaction is obviously mg cos theta. Mg cos theta into dl gives the horizontal component, dx. Integral dx is x. So this is the concept which I am going to use here. Notes pattern and good check. Let us try this week. Score at least 20 plus. I'm very confident that my theory takes you there. Same concept I am going to use. Inclined plane concept, mu m gx. Now here you started at this point without any kinetic energy. You reached at this point some b. Okay. My point is, it would have come down by, it would have come down 0.6. It would have come down from A, and this is some y1. This is some y1 depth, and this is some x1, right? So work done by gravity is mg y1. Agreed? Work done by gravity is mg y1. Agreed? Work done by friction. You are moving slowly from A to B. Minus mu mg x1 is equal to 0. Because started from rest, all the time rest also, by the way. Mostly. No change in K. So this allows me y1 is equal to mu x1. Substituted the value of mu. I require a condition phi y1 is equal to 3x1. Now tell me which number there gives you this condition. Can I take 5, 8 there? Only one that accepts this. Here, put y1 as 10. Put y1 as 10. Remember, this is minus 8, this is minus 4, and this is minus 2. Minus 2. If y means the coordinate actually. Actually, you should take 2 out of this. If you take 6, y1 is minus 8 minus of minus 2 actually. That should be taken as 6. 5, 6, 30. 3 tens, 30. Satisfied. So therefore, this is the best option. This is minus 2 and this is 0. Lot of students will do this problem correct. Till here they will come. And they will fail in identifying the option because they will ignore it is started from minus 2, not from 0. Boys and girls, do you have any doubt? Good question. But do you agreed that there is a minus 8 option here? This is minus 8, 0. Actually, you are leaving from here. So what is this distance? I think you expected me to write 8 actually. 8, 9. Right, 8. How? You started from y is equal to minus 2. Reached y is equal to minus 8. So the vertical displacement is only 6 meters. Right. Rest everything is okay. Right. Wow. Now go through this question again. 18th question. Two identical sleeves A and B, each of mass M, can slide without friction. Without friction means half of the problem is done. Yes. Yes. Very good. Thank you. See, try to understand. There are two -8s there. So I have tried my solution 10 comma -8. Not necessarily. I'm assuming some B. There is some -8 or -6. So I have tried a solution here. I didn't took, by the time when I am taking B, I don't know that is B. After closing the problem, I marked it as B. The point. So very simple. I have substituted things, or otherwise I'll express you like this. 5 times -8 minus of -2 is 3x1, taking y as -8. So 5 times 5 times -8 minus of -2. y1 అంటే అలా కాదుగా తీసుకునేది, సారీ. y1 అంటే డిస్టెన్స్ మీరు కావాలి. మాడ్యులస్. This is 5 into 6, 3x1. 2 times. x1 is equal to 10 meters. If I substitute y is equal to -8, I got x as 10 meters. So what is the point? 10 comma -8. That's all. Right. Yeah, go through this question now. Two identical sleeves, A and B, each of mass M, can slide without friction on a fixed horizontal rod. A and C, can you see that? A and a load C of A and B, can you see? Similarly, C is a load of mass 2M. A and B are of mass M. Length of the string is 3√3. For a while, take it as L. Later, we will substitute. Initially, the sleeves are separated by a distance L. The gap between A and B is L, means flat. You release it from there. Slowly, it comes down. Right. At an instant, I'm just showing you here, at an instant, when the velocity here is V1 and both might be moving with V2, say this makes an angle theta. Remember, take this part of the rope. Okay. So this end will have V1 cos theta component. Remember, this is V2. Obviously, this component is 90 minus theta. V2 cos 90 minus theta becomes V2 sin theta. Are bhaiya, this end will have V2 sin theta. This end will have V1 cos theta. So V1 cos theta is V2 sin theta, which follows from the length of the string is constant. That is the first observation. And it comes from constrained motion. Any doubts? Right, next. Are bhaiya, it has fallen down by some height. I know. What is that height? Remember, if this is L by 2, obviously this will be some L by 2 cos theta. So it has fallen. Bhaiya, this is of mass of 2m, don't forget. 2m GH is equal to the entire energy, whatever the loss you faced, the entire form is distributed in the form of K. So K means K of this plus K of this. Written there. I got one equation, V1 square plus V2 square is blah, 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 some equation. You already given one equation. I will substitute that into this. That allows me to write V1 square separately, V2 square separately. There is no space, I know. But time is the criteria. So V1 square I have. Now, all that V1 is guarded by what? This function. I need to check when that function is maximum. What is the condition to check? D by d theta of that is 0. It is possible when cos theta is equal to 1 by root 3. Substituted. When I substituted all that, I got 2 root 5 meter per second. So V1 is 2 root 5 meter per second. Or yeah, cos theta is 1 by root 3. L by 2 cos theta. L by 2 cos theta you substitute. What you will get? L by 2 cos theta. L itself is 3 root 3 by 2. Cos theta is 1 by root 3. Overall, you will get 3 by 2. 1.5 meter. Correct. Before, see what is happening is it is coming down. At some point, velocity becomes a maximum. Remember, just before that, just after that, acceleration direction will change. Till this moment, the acceleration is in downward direction. So velocity increased, reached a maximum. Thereafter, what happens? Acceleration will be in opposite direction. So that is the reason is slowing down, coming instantaneous rest. So therefore, before the sleeves collide, the net force on the system consisting of the sleeves, the cord and the load becomes 0 once. Clear? Akka? Any doubts? Right. Next, one question I will do and I will close this. But time is a criteria. Okay, we'll deal this and we'll close. 6 right. You can see two small identical discs, each of mass 1 kg, placed on a frictionless horizontal floor. They are connected by a light inextensible cord of length 1 meter. You are at the midpoint, say P is the midpoint, and you are applying a constant force 2 newtons. What is the velocity of approach of these discs when they are about to collide? Say at a given instant, here you are, this is some Vy, this is some Vy. Actually, you want 2 Vy because that is the relative velocity of approach. First, let me find Vy. For this purpose, I took this distance as y. At this point, F, tension T. So 2t cos theta is F, right? T sin theta, this is 90 minus theta. T sin theta is MA. A refers to what is A in this diagram? A two forms. dV by dt is one form. V dV by dt. That form I have used. Why I am taking minus? Because decreasing. Y is decreasing. So therefore, this is the another equation. And geometry says, what is y? This is L by 2. This is L by 2 sin theta. That I have written here. And I have differentiated that. Now, please tell me, do you have any observations in these three equations? Boys and girls. First one, equilibrium of point P. Second point, what causes AY? Third point, geometry part. Now I'll go to here. I am writing, sorry, by half. See, you said T is F by 2 cos theta. I have written that. See, what I need to write is, this is equation 1, this is equation 2, this is equation 3. See, from 1, 2, 3, what I have is minus M Vy dVy by dy is, what is a T? F by, no, that is a T sin theta, responsible for this. Okay. T refers to F by 2 cos theta times sin theta. Now this dy term, I pushed it to there. From here to here. From there, I think you know how to handle things. So I have done all that. I got mvy square by 2 is FL by 4. Vy is root FL by 2m. But you want 2 Vy. So therefore, 2Vy is, here bring 2 inside, it will become root 4, 4 by 2, 2FL by m. 2 meter per second is the relative velocity. Don't ask me one question, sir. You ignored these components. Because they are in the same direction, they will cancel. There is no relative part in that direction. The relative part is only in the y direction. I hope I have cleared this. Right, I'll stop here.